WWW. When, where, what went wrong? The question of all questions, in both production and management. Efficient production requires precise knowledge of which machine is producing what at a given time, providing an overview of energy and material use. Keeping track of exactly how much time each step in the production process takes could save German companies large amounts of resources. And that's not all, they could also noticeably reduce production costs. At MSR Technologies in the Swabian city of Laupheim, the age of efficiency has already begun. All data describing the operating conditions of the machines are captured here in what is almost real time. The information travels via wireless to a central computer, where it can be evaluated at any time. In addition, workers are able to call up all information concerning the various work orders on computers located at the production site. If a client sends an email requesting changes, it appears in no time to the machine operator. That prevents the production of components that are no longer the right size and cannot be delivered to the customer. The result is fewer faulty components and higher material savings. The entire production is managed from a control station located in the production hall. Thanks to special software, the production manager at MSR Technologies keeps his eye on all the production data at all times. Data from more than 15 machines. 160 employees work with milling machines and lathes, as well as combined milling, lathing, and drilling machines to make metal parts for the automobile industry. Most of the components are made for turbochargers, diesel fuel injections, and double-clutch transmissions. Data on the operating conditions of every single machine are collected and transmitted to the central computer. The production manager knows at any given moment whether it's maintenance, servicing, or cleaning that has interrupted production, or if it's organizational, mechanical, or electrical disturbances. One mouse click is enough to determine that in this case, the CNC multi-spindle was barely working at 2/3 capacity over the last 3 shifts. And that because of problems with the palletizing robot. The robot has stopped moving in the CNC multi-spindler area because the workpiece carriers are missing. The robot needs the carriers to hold the parts that are processed in the CNC machine. The carriers transport the parts to the next machine and are then brought back empty. If the carriers don't return fast enough from the next machine, the CNC multi-spindler stops moving and continues to use electricity in idle mode. A short discussion, and it's decided that in the future, more workpiece carriers will be in circulation, improving the productivity of the machines. Ultimately, this simple organizational measure lowers the energy use for each part that is produced, and consequently, the energy use of value added by the entire company. Just a few meters away, the system signals the next problem with another machine. This lathe is all of a sudden producing an increased number of faulty parts. 2 out of every 100 main hubs produced here for double-clutch transmissions have an outside diameter that is too large. This mechanical error is immediately communicated to the department responsible. The maintenance technician arrives shortly and is able to solve the mechanical problem. Since the production was halted just a few minutes after the problem was identified, the amount of waste was kept at a minimum, and that saves material. The constant data gathering not only leads to the speedy correction of organizational, mechanical, or electrical errors, the information helps optimize the entire production process. Data analysis determines that a rotary swagger machine would have to work 18 shifts a week to complete an upcoming production order. The rotary swagger hammers the so-called outdrives used in combustion engines into a special form. Afterwards, workers load the pieces onto a small shelf that's transported by forklift to the next stage in the production process. A fine turning machine processes the parts down to hundredths of a millimeter. But the analysis determined that the fine turning machine only needs 15 shifts a week to get the job done. As a result of the evaluation, the rotary swagger works until noon on Saturday, while the fine turning machine already starts the weekend on Friday afternoon. That means the production is organized so that this machine doesn't have to wait in standby mode for the next parts to arrive. And that saves a substantial amount of energy. Because of the continuous information available from data collection, effective management can be implemented throughout the entire company. Some machines have to work nearly around the clock without malfunction, while others have some spare capacity. That allows yet other machines to take over complete tasks, reaching 100% capacity. The result is uniform production and fewer startup losses from the machines. We measure revenue in relation to hours of production as well as power consumption, and in the last 3 years we've managed to save 10% of energy costs through a uniform and secure production process. Saving energy through fast recognition of organizational failures and a unified production process. Saving material through constant updating of work orders and a quick analysis of mechanical and electronic failures. Constant data collection and continuous evaluation within the production leads to considerable advantages for the company. And these advantages can be achieved with measures as simple as turning off a machine. At MSR Technologies, the employee's acceptance is important for the success of various measures. That means no personal data is included in the data collection system. A flat hierarchy ensures that everyone is informed about the current production from workmen to management. That leads to a problem-solving mentality and to quick and competent decision-making. When, where, what went wrong? How long does the production of each part take? Transparency and good internal communication are the answers to these questions, along with constant data gathering and continuous data evaluation. That leads to noticeably less waste and reduces energy consumption. And that helps save resources and lots of money too.